In this scenario, we needed to multiply 4 and 2/3 by 3 and 1/2. That's because the amount of chocolate chips that Jack needed was 3.5 times greater than the amount of M&Ms he needed, and the amount of M&Ms he needed was 4 and 2/3. So we'll use an area model to multiply 4 and 2/3 by 3 and 1/2. To begin with, I'll just need to figure out how big of an area model I'll draw. So I know that 4 and 2/3 is 4 holes and then 2/3 of another hole. So that means I'll draw 5 holes across. So I'll make it a 5 by, let's see, for 3 and 1/2. I know that's 3 holes and then part of another hole. So that would need 4 holes in order to model it. So I'll make a 5 by 4 setup for my area model. So we have our 5 by 4 area model now, and so now I could just go ahead and set up that we will decompose the 4 and 2/3. So we have 4 holes, so 1, 2, 3, 4. So that would be for our 4 holes. And then in this last hole is where I'll show the 2/3. So I will split these into thirds. So that's for our 2/3. And then over here is where I'll show 3 and 1/2. So we'll use 3 holes for the 3. And that's plus 1/2 when we decompose. So I will split this last rectangle, or these last holes, in half to be able to represent the 1/2. And now, like I've said, some people find it helpful to box in the amount we're actually working with. You can do that, or you can just shade it in, or you can do both. So I know that I don't have all 4 of these holes, I just have 3 and 1/2. And then I don't have all 5 of these holes, I just have 4 and then 2/3 of the next one. So that would be, stopping here would be 1/3, going to here would be 2/3. So I have 4 and 2/3 by 3 and 1/2. And again, I do think it's easier to just shade in the amount that you are working with so that you can see that as well. So I'll do that quickly here. And then just here. And then now I just need to go back and look at what we have in each section. So look at the partial products. So first I'll look to see how many entire boxes I have, or how many holes. So I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I know we have 12 holes, which makes sense because that's where we did 4 times 3. Then over here, I know I have in these holes, there are 2/3 shaded in, and I have that 3 times. I have 2/3 here, and here, and here. So if I have 2/3 3 times, I know that is 6/3. And if I look down here, we have 1/2, and we have that 1, 2, 3, 4 times. So I know that's 4 halves. I know that's equivalent to 2. So I'll put 2 there. And then remember, now the last part is to just look at, well, how many parts is this little is this hole broken into, in order to be able to determine what these 2 pieces that are shaded in represent. So again, we're just focusing on deciding what fraction is represented in this hole down here in the bottom, where we've done 1/2 of 2/3, or 1/2 times 2/3. So I see there's 1, 2, 3, 4, 5, 6 parts in the hole, and we have 2 of them shaded in, so that would be 2/6. So now I would come here and I could add, I know I have 12 plus 2. Actually, know that 6/3 is equivalent to 2 as well, so I'm just going to record that as 2 here. And then we have 2/6 to add as well. So I don't have any other fractions to add with the 2/6, so I'll just keep the 2/6 there. And then 2 plus 2 plus 2 would be 6. And then we have 1/10. So that would be 16 and 2/6. So that means 4 and 2/3 times 3 and 1/2 is 16 and 2/6. And again, we probably should have estimated in the beginning, but we can estimate now just to make sure it's reasonable. let's say 4 2/3, that's just 1/3 away from being 5 holes. Meanwhile, it's 2/3 away from 4, so I would go ahead and put that up to 5 to estimate. And then 3 1/2 could go either way. We could round that down to 3 or up to 4. We'll just go ahead and round it up. So that would mean our answer should be around 20. And our answer is 16 2/6, and I would say that is pretty close to 20, making that a very reasonable answer.